Good evening. The longest day occurred on June the 24th, so the nights are now drawing in and the summer sky is now on view from 9 p.m. Before I begin, there are two things I must say about the stars. Firstly, astronomy and space is viewed worldwide, so it is best to give an illustration showing how much of the southern hemisphere of the sky is visible from your home. It is a simple matter to work out. Subtract your latitude from 90 degrees and you will have your star horizon. For example, my latitude here in Nottingham in the UK is plus 52 degrees, so my star horizon is 38 degrees. Any object in the night sky with a declination above 38 degrees will be circumpolar and visible all year round, while you can see all of the constellations south to a declination of minus 38 degrees. Secondly, astronomers measure colossal distances in what we call light years. Light travels at a speed of 186,282 miles, that's 300,000 kilometers a second, so that in one Earth year it covers about 6 million miles, which is one light year, which is their preferred unit of measurement. Look up into the clear night sky and you will at once see the star clouds of the Milky Way. It stretches from the constellation of Perseus close to the northwestern horizon. It then meanders high overhead as it passes through Cygnus, the Swan, and then descends into the constellation of Sagittarius in the far south. This is our own galaxy as we see it from within, and a pair of 10 by 50 binoculars is enough to show the large number of open star clusters and the Coalsack Nebula in Cygnus, where the Milky Way appears to divide into two branches as a result of dark carbon soot that lies in our line of sight. Our Milky Way is a spiral galaxy containing over 100 billion stars. To put its huge size into perspective, if you could travel in a spaceship at the speed of light, it would take you 100,000 years to travel across the main disk. It has an average thickness of 1,000 light years, and there is a central bulge that is barred in shape and 15,000 light years in diameter. Our Sun is 26,000 light years away from the nucleus. The Milky Way is also rotating slowly, taking 225 million years to complete one revolution. Of course, our galaxy is only one of billions that make up the entire universe. August is the time of year when the largest number of globular star clusters are on view, many of which are visible in small telescopes despite their vast distances at the outer regions of our galaxy. Let us now take a tour of the summer constellations, and we will begin by looking into the northern sky, where we find the familiar saucepan-shaped pattern of stars we call the Plough, Ursa Major, which has descended halfway down the northwestern sky with its handle pointing upwards and its bowl low down. The two lower stars in the bowl, left to right, are named Merak and Dubhe. They are known as the pointers because they lead the way across the sky to the pole star, Polaris, in the tail of the little bear, Ursa Minor. The small saucepan-shaped pattern of this constellation points high up in the sky. From top to bottom, the stars of the Plough are named Alkiad, Mizar, Alioth, Megrez, Fad, and then the pointers Merak and Dubhe. Mizar is a fine double star system visible in binoculars and is sometimes referred to as the Horse and Rider. There are two deep sky objects to see this month using small telescopes: the galaxies Messier 101 and Messier 51, to either side of the stars Alkiet and Mizar in the handle of the plough. Suggestions of their spiral arms can be glimpsed using telescopes of 4 inches and above. Messier 101 is known as the Pinwheel Galaxy and is visible in small telescopes shining at magnitude plus 7.9. Although it extends 22 arc minutes on photographs and is quite bright, only the central region of this galaxy is visible in small telescopes and it is best observed using low powers. Messier 51, the Whirlpool Galaxy, shines at magnitude plus 8.4. For the amateur, Messier 51 is easy to see and a showpiece if the sky is dark, but it is quite sensitive to light pollution, which can easily make it fade into the background. Now follow the line from the pointers an equal distance and you will arrive at the W-shaped constellation of Cassiopeia, the Queen, and just below is Perseus, the hero. The main star, Merphak, can be found by a line drawn from Gamma and Delta Cassiopeia and prolonged. This is the location of the famous double star cluster NGC 869 and 884, which is a lovely sight in binoculars and small telescopes. It is one of the finest star clusters in the night sky. It is also the scene of the famous annual Perseid meteor shower, which begins on July the 27th and reaches its peak activity just before dawn on August the 12th, when over 70 shooting stars an hour may be seen. Unfortunately, this month the moon is just past full, which may make it harder to see the shower. However, a number of bright meteors will still be seen on the night of August the 11th to the 13th. The bright star Capella, which is the most luminous star in the constellation of Auriga, the Charioteer, lies low down close to the northern horizon, while the brilliant blue star, Vega, lies overhead. Vega is one member of what is known as the Summer Triangle, which is formed using the 2 nearby stars of Deneb in Cygnus the Swan and Altair in the constellation of Aquila the Eagle. The blue colour of Vega indicates that it is hotter than the Sun. It is also 50 times as luminous, so that it ranks as a giant star even though it is very feeble compared with searchlights such as Rigel in Orion. Its distance is 26.5 light years. The Sun's own motion in the galaxy is carrying it in the general direction of Vega at a rate of 13 miles per second, but this does not mean that there is any danger of a collision. Vega is one of the loveliest of the bright stars. Binoculars bring out its blueness really well. The rest of the little constellation of Lyra is not conspicuous, but it contains more than an average share of interesting objects. First, there is the famous naked eye double, Epsilon Lyra, which may be found close to Vega. Normal-sighted people can see that it is made up of 2 stars of magnitude plus 4.7 and 5.1 side by side. Telescopically, each component is again double, so that Epsilon Lyra is a double-double or quadruple star. The components are easily visible in a 3-inch refractor. The rest of Lyra is made up of a 4-sided figure of stars, of which the brightest is Gamma, shining at magnitude plus 3.2, which is named Sulfurfat. Beta Lyra, or Chalique, to give it its proper title, is a well-known variable. Its light curve is remarkable, and it is always changing in brightness. Starting from magnitude plus 3.3, it fades down almost to the 4th magnitude, it recovers to its maximum and then fades again, this time to as far as 4.3. In fact, there are alternate deep and shallow minima, so that it is quite unlike a short period Cepheid. The odd behaviour of Beta Lyrae was first noted in 1784 by John Goodrick, the young deaf mute who realised that Algol in Perseus is an eclipsing binary. Goodrick thought that the same explanation must hold good for Beta Lyrae, and again he was quite right, but there is an important difference. With Beta Lyrae, both stars are highly luminous and they are so close together that they almost touch, with the result that both are drawn out into shapes not unlike eggs placed end to end. There are other noteworthy features in Lyra. In particular, there is a fine example of what is known misleadingly as a planetary nebula, in fact a faint hot star with an immense gaseous atmosphere. At magnitude plus 8.8, Messier 57 is the brightest planetary nebula in the sky, which lies directly between Beta and Gamma Lyrae. This photo was taken by Terry Hancock, who lives in Fairmont, Michigan in the United States. The Ring Nebula can be seen in small telescopes, although its central star is too faint to be seen. Cygnus the Swan is more often termed the Northern Cross, since its X-shaped pattern is so prominent. Deneb, its leading star, is of the first magnitude, but since it is ranked as 1.3, it is more than a full magnitude fainter than Vega. Appearances are deceptive. Deneb is one of our searchlights and is very remote. It lies at a distance of 3,200 light years. Its exact candle power is uncertain, but it must be as powerful as of at least 10,000 suns put together, and it is slightly yellowish in colour. The cross of Cygnus is marked by Deneb together with 4 other stars: Gamma, magnitude plus 2.2, Epsilon, 2.4, Delta, 2.9, and Beta, plus 3. Of these, Beta, often known by its proper name of Albario, is the most interesting. It is fainter than the rest and further from the middle of the X, so that it spoils the symmetry of the pattern. It is a glorious telescopic double with a yellow primary and a bluish or greenish companion, which is visible in small telescopes. Halfway between Beta and Gamma lies a 4th magnitude star, Eta Cygni. At times, a similar star may be seen close to it. This is Chi Cygni, a variable quite different in nature from the Cephids or the Algol type eclipsing binaries. It has a long period amounting to more than 406 days, and it has a considerable range in brightness. The star was at maximum brightness, magnitude plus 3.3, on June the 9th, 2014. At its best, it may equal Eta, but at near minimum it becomes so dim that large telescopes are needed to show it. It is visible to the naked eye for only a few weeks during its cycle, so now is the best time to see it. Chi Cygni is a typical long period variable, and like most of its kind, it is strongly red in colour. The Milky Way passes straight through Cygnus, running from Cassiopeia in the northeast and continuing into Aquila. Here is a nice photograph taken by Oliver Czerzenitz of Austria, showing the star Gamma Cygni, or Sadur, to give it its proper name. It is the central star of a Northern Cross and lies at a distance of 1,800 light years. The milkiness is particularly strong in Cygnus, and it is easy to see that the shining band divides into 2 portions, one branch petering out after some distance, while the other extends over the horizon. There are many glorious star fields. Altogether, Cygnus is one of the most spectacular regions in the northern sky. Around the bright star Deneb is NGC 7000, also known as a North American nebula, due to its appearance. It shines at magnitude plus 4 and makes an ideal photo opportunity. This photograph was taken by Oliver Czerzenitz. The North American Nebula is distinctly red in colour and large, covering an area of more than 4 times the size of the full moon. But its surface brightness is low, so normally it cannot be seen with the unaided eye. This is another image, this time taken by Jeff Johnson, who lives in Las Cruces, New Mexico, in the United States. Binoculars and telescopes with large fields of view, approximately 3 degrees, will show it as a foggy patch of light under dark skies. Altair, the brightest star in the constellation of Aquila, the Eagle, is the last member of the Summer Triangle. Unlike Deneb and Vega, it is not circumpolar anywhere in Britain or the United States. It passes well below the horizon. Once Vega and Deneb have been found, Altair should follow at once, particularly as it has a fainter star to either side of it. Altair is one of our nearest neighbours in space. It is 16 light-years distant and 9 times as luminous as the Sun, so that it is a minor star compared with Deneb. Yet it has a hot surface and is pure white. Aquila itself really does give an impression of a bird in flight. Several of its stars are above magnitude +3, though no can rival Altair, and the general pattern is quite distinctive. Flanking Altair are Gamma, magnitude +2.7, and Beta, 3.9. Gamma is reddish in colour. Below the bright star Altair lies 3 more stars, Theta, magnitude +3.3, Eta, which is variable, and Delta, 3.4, arranged in a line. Eta Aquila is a Cepheid fluctuating between magnitude +3.7 and 4.5 in a period of just over 7 days. Beta makes a good comparison star. Aquila, like Cygnus, is caught up in the Milky Way. The main branch goes straight through it, passing by Altair and continuing to the last bright star in the constellation, Lambda, magnitude 3.4. This provides an extra means of locating Aquila if the sky is sufficiently dark and clear for the Milky Way to be seen. Scutum the Shield is a small faint constellation. Hevelius, the 17th century astronomer who produced a good star catalogue, had a passion for inventing new constellations. Hevelius wanted to honour John Sobieski, the King of Poland, who had defeated the Turkish army at the Wars of Vienna. Accordingly, he separated off a small part of Aquila, close to Lambda, and named it after Sobieski's shield. However, Scutum has become firmly established as an independent group, and it does at least contain a bright section of the Milky Way. There is also one open cluster, Messier 11, which is visible with the naked eye. This image of the cluster was taken specially for our programme by Terry Hancock and shows all of its stars really well. Telescopically, it is a lovely sight and is often nicknamed the Wild Duck. Shining at magnitude +5.8, it was discovered by Gottfried Kirch in 1681, and Charles Messier included it in his catalogue in 1764. The Wild Duck cluster is one of the richest and most compact of the known open clusters, containing about 500 stars. Its age has been estimated to be about 220 million years. Look for it a short distance from Lambda Aquila and you will probably see it, but it appears only a small patch, and the Milky Way is so bright nearby that identification of a cluster can be difficult. The area enclosed by imaginary lines during Deneb, Vega, Altair and Epsilon Pegasi contains 4 small constellations. Of these, the only one which may be recognised at once is Delphinus. Its brightest stars are only slightly above the 4th magnitude, but there is a compact little group of them, appearing almost like a very loose cluster in shape. The dolphin appears vague resemblance to a tiny dim and distorted plough. The constellation Hercules lies midway between Vega and Arcturus. It is large and sprawls southward for some distance, but its two brightest stars, Beta and Zeta, are only of magnitude plus 2.8. The shape of the constellation resembles a keystone, and it contains two notable objects. The first is a star cluster of a type quite different from the Pricep, Messier 44, or the Pleiades, Messier 45. It is known as Messier 13 and is termed a globular star cluster since its 100,000 stars are arranged in the form of a vast sphere. It is the only globular cluster visible to the naked eye from Europe or the United States. There are two globular clusters, which are brighter, but both lie in the far south, only visible in the southern hemisphere, Omega Centauri and 47 Tucana. Here is a star chart showing all the constellations visible from Australia, latitude minus 34 degrees. As seen from Adelaide, the constellation of Centaurus, the Centaur, is visible high in the southeast, and Omega Centauri, NGC 5139, lies in the main figure close to the Milky Way. It is of magnitude plus 3.9, so it is easily visible to the naked eye. The constellation of Tucana lies high in the northwestern sky, and 47 Tucana, NGC 104, is situated on the border with the nearby constellation of Hydrus, close to the small Magellanic Cloud. The globular cluster is of magnitude plus 4, so again it can be seen with the unaided eye. This photograph of Messier 13 was taken by Terry Hancock. Messier 13, shining at magnitude plus 5.9, is a very elusive object to the naked eye and may be seen only when the sky is both perfectly clear and dark. The guide star is Zeta Hercules, magnitude 2.8. North of Zeta lies a fainter star Eta, plus 3.5. The globular cluster lies directly between the two, rather closer to Eta. The Milky Way hosts about 200 globular clusters. They form a halo of roughly spherical shape, which is highly concentrated around the galactic centre. In the Sagittarius, Scorpius, Ophiuchus region, as shown in this photograph taken by Noodle Van. The most distant galactic clusters, such as NGC 2419 in the constellation of the Lynx, are located far beyond the edge of the galactic disk, at distances out to 300,000 light years. The Hercules cluster, for instance, lies at 34,000 light years away, and they make up a kind of outer framework to the galaxy. Globulars are quite different from open clusters. Globular clusters are vast symmetrical systems containing from 10,000 to millions of stars and are strongly condensed. An average globular cluster has a diameter of 65 light years, although there is a wide range in both size and mass. Careful studies of the motion of the stars inside globular clusters show that around 40 clusters resolve backwards or retrograde as compared to the rest. Because globulars are so old, their leading stars are highly evolved, red giants, and there are also some stars that are hot and blue, which are known as blue stragglers. Today, some astronomers believe that a third of the entire globular star clusters may be captured dwarf galaxies. The second notable object is Alpha Herculeus, or Rassilanthe. It will be found close to Rasselhague in Ophiuchus. The names are confusingly alike, but the stars are not. Alpha Herculeus is a magnitude fainter and is red, though its colour is barely detectable with the naked eye. Alpha Herculeus is an irregular variable. It changes slowly and unpredictably between magnitude +3 and 3.5, and its fluctuations may be followed without optical aid, particularly as there are several useful comparison stars not far off. It is of the same kind of variable star as Betelgeuse and Orion, though it is not as luminous and is only 410 light years away. Like Betelgeuse, it is of tremendous size. Ophiuchus contains several bright stars, as well as Alpha, which shines at magnitude +2.1. There are 8 more above magnitude 3.5, but there is no well-known pattern, and most of the constellation is barren. Alpha makes up a sort of kite shape with Vega, Altair and Deneb, but probably the best way to find it is to look directly between Altair and Arcturus, rather closer to Altair. Alpha Ophiuchi is the brightest star anywhere in this region, and so should be identifiable. Alpha Ophiuchi is one of a triangle of stars, the other two being Kappa, magnitude +3.2, and the red variable Alpha Herculeus. There are 2 other parts of Ophiuchus recognisable without difficulty. The little group of 5 stars below Alpha, of which Beta at magnitude +2.8 is the brightest, is quite conspicuous. Further south lies a curved line of 4 stars, of which Delta, magnitude 2.7, and Epsilon, 3.2, make up a notable pair. Ophiuchus covers a large area and contains 6 globulous clusters, all listed in the catalogue of Charles Messier, and which are easily visible in small binoculars, since they are brighter than magnitude +7. Of course, if you have an interest in photographing deep sky objects, these will be a nice challenge. Rio Ophiuchus is a faint magnitude +4.6 star, lying just above the bright star Antares. Not only is it a nice multiple binary, it is also located in a nebula that is one of the closest star-forming regions to the solar system. This cloud covers an area of 4.5 by 6.5 degrees of the celestial sphere. It consists of 2 major regions of dense gas and dust. The first contains a star-forming cloud and 2 filaments, while the second has a star-forming region and a filament. While it can be seen in small telescopes, photographs of the region by amateurs bring out its glorious colours, making it a lovely area of the sky. Serpens is a peculiar constellation. It consists of 2 separate parts. It is meant to represent the snake with which Ophiuchus has been doing battle. The head, Serpens caput, lies to one side of Ophiuchus, and the body, Serpens cauda, to the other. If you look low in the south during a late evening in August, you can hardly fail to notice a star, which is not only very bright, but also very red. This is Antares in Scorpio. Its name means the rival of Mars. The Greek name for Mars was Eris, and it is certainly the reddest of the first magnitude stars. Antares lies well away from any of our usual pointers, but this does not matter so much as there is no star of comparable brightness anywhere near it. Antares has many claims to fame. It is a large and luminous red giant, and more than 3 times as powerful as the Sun, and with a diameter of some 300 million miles, so that it is even larger than Betelgeuse in Orion. It is 350 light years away, and it has a faint green magnitude 5.1 companion visible in small telescopes. The only point of regret to Britons and North Americans is that Antares never rises high above the horizon, so that low-lying haze will hide it. This also applies to the rest of Scorpio, which is a magnificent constellation when properly visible. Since it has a distinctive outline and is made up of chains of stars, it is extremely easy to recognise as soon as Antares itself has been found. The Scorpion's head consists of several bright stars arranged in a roughly north-south line, of which delta at magnitude plus 2.3 and beta 2.6 are the most conspicuous. A second line, decidedly curved, runs down towards the horizon and includes Centaurs. The British horizon cuts off Scorpio halfway, and the brilliant sting, of which one member, Lambda, at magnitude plus 1.6, is the equal of Castor in Gemini and never rises at all. From Australia, all of Scorpio can be seen, which lies in the Milky Way, so that it is an exceptionally rich area. Next to Scorpio lies Sagittarius, the celestial archer. Like Scorpio, it belongs to the zodiac and is crossed by the Milky Way. Also like Scorpio, it is too far south to be well seen from Europe or the northern United States. Sagittarius has a number of bright stars, but is not easy to recognise because of its lack of well-defined pattern. If Antares can be seen, simply look to the east along the horizon and you will come to Sagittarius. The northern part of the group contains one bright star, Sigma, which is magnitude plus 2.1, and several others of above the third magnitude. Further south, invisible from Britain, but rising in New York, is Epsilon, which shines at magnitude plus 1.8, is the leader of the constellation. However, the main glory of Sagittarius lies in the star clouds, which make up this part of the Milky Way. When we turn our eyes towards Sagittarius star clouds, we are in fact looking towards the very centre of our galaxy. The actual centre cannot be seen because there is too much gas and dust in the way, but luckily the modern science of infrared and radio astronomy has come to our aid, since infrared and radio waves can penetrate the interstellar matter and give us information about regions which we can never see. To professional astronomers, this is one of the most fascinating parts of the whole sky, and the naked eye observer can at least appreciate the beauty of it. Keen-eyed watchers may also be able to make out the misty speck which marks the Lagoon Nebula, Messier 8. It is a tremendous gas cloud of the same type as the Orion Nebula and is spectacular when seen through a telescope. This image, showing the Lagoon and Trifid nebulae, was taken by Brian Pablo. The constellation contains the Omega Nebula, Messier 17, which is a gaseous nebula shining at magnitude plus 7, and the splendid Trifid Nebula, Messier 20, also of magnitude plus 7, which are visible in a pair of 10 by 50 binoculars. However, their colourful displays are best seen in longer exposure photographs, as seen here. Here is another wide field photograph of the area, this time taken by Terry Hancock, showing both the Omega Nebula and Trifid as they appear together in the star clouds of the Milky Way. This image of the Omega Nebula was processed by Roberto Colombari, who lives in Brazil, and shows the nebula in fine detail. The image is a narrow-band composition. The narrow-band frame was assembled using 40 panels from the Saburo telescope of Mauna Kea in Hawaii, using red, green and blue data from the previous image by Mr. Robert Jengler. The Omega Nebula lies at a distance of 5 to 6,000 light years from the Earth, and it spans 15 light years in diameter. This is a splendid photograph of the Trifid Nebula taken by Oliver Serzanitz using a 5.2-inch TS Photoline F5 telescope. The nebula was discovered by Charles Messier on June the 5th, 1764, and its name means divided into 3 lobes. The object is an unusual combination of an open cluster of stars, an emission nebula, the lower red portion, a reflection nebula, the upper blue portion, and a dark nebula, the apparent gaps within the emission nebula that cause the terrific appearance. The nebula lies at a distance of 5,600 light-years. Sagittarius also has its own share of several globular star clusters, all of which are visible in small telescopes. The last of the summer groups is Libra, the scales, which is a zodiacal constellation but is otherwise indistinguished. It is at its highest during evenings in July, but it is too faint and too vague to be easily identified. After watching this month's programme, hopefully you are now feeling inspired to go outdoors and look up into the clear summer sky and see some of the nice sights on view. The splendour of the Milky Way crossing the night sky and some of the globular star clusters. That is all we have time for this month. I would like to acknowledge the kind help of Zlatko Orbanik, Oliver Serzenitz, Terry Hancock, Noodle Van, Roberto Tolombari, Robert Gensler, Jeff Johnson and Brian Pablo, who provided all of the images for this month's programme. If you are interested in photographing the stars, Amateur Astrophotography magazine is recommended. It is a free monthly publication, so do visit the website at amateurastrophotography.net. Also, please visit our own website, Vimeo, where you can watch all of the past shows of astronomy and space. And if you like this programme, please share it with your friends and members of your local astronomical society. Until we come back next month, good evening.